This is a video on C2 Edexcel Chemistry Topic 4, which is about groups in the periodic table. It's quite a short topic, just talks about specific groups in the periodic table like metals, alkali metals and halogens and a few others. So we'll just go through those bit by bit. So metals are found on the left of the periodic table and in the middle. So they're found on this side and in the middle, generally over here. There's transition metals over here as well. So most metals, so transition metals are the centre block part of it, alkali metals on the left hand side. So most metals have really typical properties. They're malleable, which means they're bendy and good conductors of electricity. It also means they can be hammered into shape. Most metals are the transition metals. They have typical properties such as a high melting point, and they make colourful compounds. So copper sulfate is blue, potassium chromate is yellow, potassium permanganate is purple. The reason why metals have these properties is due to the structure of the metals and the special type of metallic bonding that happens within the metals. So metals have a regular arrangement of atoms. They're held together by metallic bonds. This leads to a giant structure consisting of positive ions with a sea of free electrons that are actually in between them. So we call those free electrons in chemistry delocalized electrons. So these delocalized electrons allow the metals to conduct electricity. This giant regular structure has a whole set of these free electrons, and they can move wherever they wish, and that's what actually allows metals to conduct electricity. So this metallic bonding and strong bonds ensure that the metals have a high melting point and therefore a high boiling point, and also it means that metals are generally insoluble. You can't dissolve them in other solutions. The layers in the atoms can slide over each other, so this layer can slide over this layer, which makes them malleable, just like graphite. So in other words, it can be hammered up into shape. So now let's talk about the alkali metals. So alkali metals are a specific group of metals. They're on the left hand side of the periodic table. So that's group 1. So the alkali metals are also known as soft metals, okay, and they have low melting points when compared to other metals. So lithium, sodium, potassium are all alkali metals. They're the three that most often mentioned. They all react with water to form hydroxides. So if you put an alkali metal in water, it makes a hydroxide and it makes hydrogen gas. So lithium plus water, sodium hydroxide, hydrogen. Sodium plus water, sodium hydroxide plus hydrogen. Potassium plus water, potassium hydroxide plus hydrogen. So I think it's a plus water probably. But it always makes hydrogen gas, and it always makes lithium hydroxide. Remember the test for hydrogen gas from C1, you put a flame or a lighted splint into hydrogen and it makes a pop. As you go down the group, so that's you start at the top of the group and you go down, the atomic number of the alkali metal increases, so their properties change. As you go down, the melting point decreases, the densities increase, they become softer, but they also become more reactive. So towards the bottom end, potassium, that's more reactive than the top end, lithium. You'll probably seen lithium, sodium, potassium in a school, in a lab, put in water and the reaction take place, but rubidium and cesium are considered to be too reactive in the classroom. Francium is also radioactive and really rare. It's only ever around in a few grams in the whole of the Earth's cross-secting time. It's due to its half-life, which is very, very short, which you'll learn about in P2. Alkali metals are more reactive as you go down the group because that one single electron, group 1 electron in the outer shell, is further away from the nucleus. Therefore, it reacts a little easier to actually leave and join another ion to become for ionic bonding to take place. The further away it is from the nucleus, the weaker the force of attraction. The weaker the force of attraction, the easier it is to actually lose the electron. Therefore, the more reactive it is. Group 7, halogens. Okay. So halogens are group 7. They are 1 electron short of an outer shell. So in other words, they have 7 electrons in the outer shell. Group 7, 7 electrons in the outer shell. They are very reactive because they only need 1 electron, and that makes them very, very useful. So all halogens have similar properties. Chlorine is fairly reactive, it's poisonous and dense green gas. Bromine is dense, just like chlorine. It's poisonous, just like chlorine. It's an orange liquid, so it's coloured, just like chlorine is. Iodine is a dark grey crystalline solid. Okay, so it's got a very specific colour, but different properties. It's so dense it's now become a solid. Halogens react with metals to form metal halides, for example. Aluminium plus chlorine makes aluminium chloride. Halogens react with hydrogen to form soluble hydrogen halide. They can dissolve in water to form acidic solutions. So here we have chlorine plus hydrogen to make hydrochloric acid, HCl, or hydrogen chloride, as you've seen before. That's hydrogen chloride gas. If it's dissolved in water, it produces hydrochloric acid. The higher up group 7 an element is, the more reactive it is. So the higher up it is towards the top end, the more reactive than the bottom end. This is due to the fact that the outer shell is closer to the nucleus, and therefore it attracts an electron more easily. Because it's after one electron, it'll attract it easier if it's closer to the nucleus. That positive nucleus to pull in another electron a lot easier. A more reactive halogen will displace a less reactive halogen. This is called a displacement reaction. So relative reactivity of halogens can be shown by their displacement reactions with halide ions. Sorry. In an aqueous solution. So you've got chlorine plus 2Cl leads to 2Ci leads to iodine plus 2Cl, 2KCl. So you can see that iodine has been displaced by chlorine, which is more reactive. It's further up the periodic table, it's more reactive. Noble gases, which is the final topic in topic 4. So noble gases are inert. In other words, they don't react. They're completely colourless. Okay. The reason they don't react is because they already have a full outer shell. The noble gases were discovered by chemists noticing that the density of nitrogen made in a reaction was differed from the density of nitrogen obtained from air. They then thought the nitrogen obtained from air must have other gases within it, and they discovered that there were different noble gases actually within the air. And they actually found these by performing fractional distillation of air, and we talked about fractional distillation in C2 topic 3. So the properties and uses of noble gases include the inertness. So they're all inert, so therefore they're useful for having this inert atmosphere for welding and in filament lamps. So argon is generally used for that. They have a low density, so it's useful for filling balloons and airships, so that's helium. And they're not flammable. So this is to prevent hot filaments from burning away, and that's what argon does. So the boiling point of noble gases follows a clear pattern. In an exam, you may be given a noble gas with an unknown boiling point and asked to predict it. The same idea can be used to predict density that increases as you go down the group. So you can see that the boiling point increases as you go down the group, as you go down from helium through neon, through argon, etc. You can see the boiling point increases. Density happens. Density is the same. Density will increase as you go down the group. And that is the end of topic 4 of C2 Edexcel Chemistry.